Correlation analysis in Python. Welcome to your first lesson on correlation analysis. Correlation helps us find relationships between variables. You will learn how to use Python to spot patterns in data. Let us get started and discover why this is a valuable tool. Running the cell now. First, we will bring in two Python libraries. numpy helps us with numbers and calculations. Pandas helps us organize and work with data in tables called data frames. Pandas is used for data tables. numpy lets us easily work with numbers and math. Running the cell now. What is correlation? Correlation is how much two things change together. If one goes up when the other goes up, that is a positive correlation. If one goes up and the other goes down, that is a negative correlation. No pattern means no correlation. Running the cell now. Now, let us make a small table of data. We will track temperature and how many ice creams are sold. These are two lists, one for temperature, one for sales. Here we build a data frame, which is like a spreadsheet. We use data frame from pandas to create this table. Let us look at our simple data set. Running the cell now. Try changing the numbers in temperature or ice cream sales to see what happens. Let us check what columns, or labels, are in our table. This line shows us the names of our variables. Running the cell now. Why check for correlation? It helps us predict and understand data. For example, if ice cream sales go up when it is hot, shops can prepare more for summer. It is helpful in science, finance, sports, and more. Running the cell now. Now let us check the correlation. We are comparing two columns, temperature and ice cream sales. The core method calculates the relationship. Running the cell now. Let us pause to see what this number means. Correlation values range from -1 to 1. Positive values mean the variables move together. Negative values mean they move in opposite directions. Near zero means there is little or no connection. Running the cell now. Pause here and ask yourself, can you explain in your own words what a correlation of 0.9 means? Now let us try an example where numbers go in opposite directions. We will see what happens as days left drop and cookies drop as well. Here is our table. The core method lets us find their relationship. If the number is negative, they go in opposite directions. Let us print the new correlation value. Running the cell now. Quick recap. Correlation above 0, both go up together. Correlation below 0, one goes up, one goes down. Closer to 0, not much connection. Running the cell now. Here is what happens when there is no real connection. We use random numbers, which means they do not follow any pattern. Setting the seed means you will see the same random numbers each time. Let us print the table and the correlation value. If the result is near 0, it means no connection. Let us see what answer we get. Running the cell now. Pandas can check all correlations in a data frame at one time. This makes it easy for larger tables. Running the cell now. Sometimes you might want to add another variable. Here we add a column for how much was spent on ads. We print the new table and then check all correlations again. Running the cell now. Let us try making your own variables. You can try out your own example now. Type numbers separated by commas for both variable lists. The code will split these into lists of numbers. We put them into a table. The correlation will show the connection between your numbers. Let us print the table and the result. Running the cell now. Try putting in a rising and falling pattern to see what happens. Real-world data is sometimes missing values. Here we remove one value with nan, which means not a number. Pandas will skip missing data when finding correlations. Let us print the updated table and the correlation matrix. Running the cell now. Sometimes you want to find only relationships where the connection is positive. We can filter for correlations above 0. This prints out just the positive ones. Running the cell now. Now let us try a mini project with more variables. This table shows movie ticket sales, popcorn, drinks, and how many rainy days there are. Remember, real-life problems often involve more than 2 columns. Here is our data table. Running the cell now. Now we check all the relationships at once. Let us see which sales move together and which do not. You can use this approach for bigger projects too. Running the cell now. Practice, which 2 things in this table have the strongest link? Write your guess before you look at the numbers. If you are learning something, like and subscribe to see more videos. You might want to see which 2 columns are the most related. We sort all variable pairs by their correlation, from highest to lowest. Self-correlations, where a column is compared to itself, are skipped. This helps you spot top links quickly. Running the cell now. Let us look at a common mistake. If your columns do not have the same number of values, Python gives an error. Here is an example of what happens if you mix up the lengths. Running the cell now. If you ever want to remove any rows with missing data, use dropner. Here is our clean table and the new correlation value. Running the cell now. Try it yourself, remove a value in any column, and see what happens to the result. Here is a quick challenge for you. Write your own code similar to what we did earlier. Pick 2 things from your life you think might be connected. Try to find their correlation. Pause and give it a go. Running the cell now. Recap, what have we learned? Correlation tells us how 2 things move together, or not. We learned how to use Python, pandas, and numpy for this. Positive, negative, and 0 correlations all have meaning. We tried examples, mini-projects, and your own inputs. Keep practicing on your own data. Running the cell now. Thanks for watching. Like the video if you found it helpful. Comment below with what data you want to analyze next. Do not forget to subscribe so you do not miss the next lesson. Share this video with your friends who want to learn Python. Running the cell now.